Hi, welcome to this lesson on calculus. What is the derivative? Let's have a look at deriving from first principles, question 6. Again, the derivative, first derivative f prime x, is defined as the limit as h approaches 0 of the average gradient formula, f of x plus h minus f of x all over h. So again, let's do our algebraic gymnastics on the side. So f of x is a surd function, the square root of x plus 1. Now, f of x plus h, so wherever there's an x, I replace it with x plus h. So that's the square root of x plus h plus 1. Okay, so let's go ahead and do that sum there, that difference. So we have f of x plus h minus f of x. That's the square root of x plus h plus 1 minus the square root of x plus 1. So this again is very similar to that square root x problem that we looked at, where we're going to use some sort of rationalizing of surds. So if I divide this by h, I'm dividing this entire expression by h, then what is that conjugate term that I'm going to multiply? It's going to be times, so we said it is the square root of x plus h plus 1. Then we change the sign. That's what the conjugate is for rationalizing, right? So plus the square root of x plus 1 all over the same expression, right? Because we're multiplying by 1. That's essentially what rationalizing is doing. X plus h plus 1. Again, just very heavy algebraic gymnastics. That's all we got to be careful about, our fluency in the algebra. Okay, so what do we have here? So in the numerator, we have x plus h plus 1 minus the square root of x plus 1 times the square root of x plus h plus 1 plus the square root of x plus 1 all over. Now in the denominators, I got that h term there times this entire expression, square root of x plus h plus 1 plus the square root of x plus 1. Okay, so why do we rationalize? Because some terms will cancel, right? So this square root terms here are exactly the same. So when I multiply them together, it's essentially that term squared, right? 2 times 2 is 2 squared. So square root of x plus h plus 1 times itself is that expression squared. Then notice here, we're going to have this term here plus, so I'm going to write it on the top here. We're going to have square root of x plus h plus 1 times the square root of x plus 1 when we expand the first and last term. Then for the inner term here, we're going to have a negative square root x plus 1 times the square root of x plus h plus 1. So if we do rationalizing correctly, we see that these terms will cancel each other out. Then minus that square term x, or the square root term x plus 1, right? Square root of that. And then because we're multiplying by itself, we are squaring it all over h times the square root of x plus h plus 1 plus the square root of x plus 1. So again, heavy algebraic gymnastics. Make sure that you have trained at the algebra gym when you come to do these questions, right? Because we've got to make sure our algebra is on point. Okay, so when we square and square root these, right, it'll simply just become x plus h plus 1 minus the square and square root cancel, and it's minus that entire term. That's really important. Okay, all over, I'm just going to call that capital D for the denominator, but essentially it's this term here. Okay, so what do I have left over? So I have x minus x cancels, 1 minus 1 cancels. So it's h all over h times the square root of x plus h plus 1 plus the square root of x plus 1. So now these h's will divide into each other. And lastly and finally, we can now evaluate the limit at long last. So it's the limit as h approaches 0 of. So this entire thing we worked out was 1 over the square root of x plus h plus 1 plus the square root of x plus 1. Now I can evaluate the limit. So it's 1 over the square root of x plus 0 plus 1 plus the square root of x plus 1. So again, in my denominator, that becomes root of x plus 1 plus the root of x plus 1. So again, I see I have two amounts of the same term. So I have 1 over 2 times the square root of x plus 1. Again, you can see it's very similar to that root x1. It's 1 over 2 times that function now. Okay, so this was quite a heavy hitter one in terms of the algebraic gymnastics, But that is the whole purpose of taking mathematics as a language and building upon all the knowledge to answer more complicated, intricate problems. All right, so that's how we would do this type of problem. I'll see you in the next one.